Download this code from codegive.com, link in the description below. Adjusting chunk size for streaming datasets, a comprehensive tutorial, GitHub 3499 context. This tutorial explores optimizing chunk size when processing streaming datasets, focusing on scenarios similar to those encountered in a hypothetical GitHub repository, let's call it repo 3499, dealing with large-scale data streams. We'll use Python with the pandas library for demonstration, but the principles apply broadly across various data processing frameworks. Since repo 3499 is a hypothetical example, we will use a simulated dataset representing potential data found in a real-world scenario involving GitHub Actions or similar. Understanding the problem, why chunk size matters. Streaming datasets, unlike static datasets that reside entirely in memory, are processed in parts, chunks. The chunk size significantly influences performance and memory consumption. Small chunk size leads to frequent I/O operations, reading from disk or network, potentially bottlenecking processing. This might be preferable if memory is extremely limited. Large chunk size reduces I/O but increases memory usage per chunk. If the chunk size exceeds available RAM, it leads to memory exceptions, halting processing. Finding the optimal chunk size involves balancing I/O overhead with memory constraints, specific to your hardware and dataset characteristics. Simulated GitHub repository data, repo 3499. Let's simulate data from repo 3499, focusing on GitHub Actions runs. Each row represents a single run, containing information such as event, runner, status, and duration. Processing with chunks *. We'll use the chunk size parameter in pdread_csv to control the chunk size. Experimenting with chunk size *. The optimal chunk size depends on factors like available RAM *, monitor memory usage while increasing chunk size. Use tools like Cudil or system monitors to track this. CPU and I/O * observe processing time as you vary chunk size. Smaller chunks might result in more overhead due to I/O, larger chunks could be CPU bound. Dataset characteristics * the nature of your data, example size, complexity, will influence the optimal chunk size. Experimentation code *. Advanced techniques *. Dask * for truly massive datasets that exceed available RAM, consider using Dask, a parallel computing library for Python. Dask handles data in parallel chunks, enabling efficient processing of datasets much larger than what pandas can handle directly. Memory mapping * if your data is on disk and relatively static, memory mapping can improve performance by directly accessing data from disk without loading it all into RAM. Data sparsity * leverage the structure of your data. If much of the data is sparse or repetitive, consider techniques like compression or specialized data structures to reduce memory footprint. Conclusion *. Finding the optimal chunk size is an iterative process of experimentation and optimization. By monitoring memory usage, processing time, and adapting the chunk size accordingly, you can significantly improve the performance and efficiency of your streaming data processing pipeline, regardless of whether it involves a hypothetical GitHub repo, 3499, or a real-world application. Remember to replace the simulated data with your actual data source and adjust the processing steps to match your specific analytical goals.